Recording. Good morning, everybody, and welcome to Astronomy 100. Today is October 4th. We have a very important task today to complete, and that is the midterm. Some of you did not finish it. By the time this recording hits you, probably you still have probably a few hours if you didn't already take care of it. So you really should have taken care of it by now. If not, this is really the last warnings, I would say. Some of you, the ones who did not actually do it today, they should have received a message from me today. So this is a very important exam, and it could impact your grade a lot, okay, if you don't do it, especially if you don't do it, okay? And taking care of it is really very important, okay? So that really overshadows everything else that we have this week, at least to the end of the day for this class. So this is a very important task. Other than that, we have the normal stuff that we have for this week, namely the review, the objectives, and the topics that we're going to be covering, and a new project that actually is posted also for you guys. First of all, there was a project that was posted last week, and that project was not really available until this morning. That's when it's going to be available. It is available right now, actually, along with another project that you guys should have received, okay? The order of these projects really in terms of their importance, or in terms of their actually how you're going to do them, is different, big time. One of them requires, and it's a mandatory, not an option, that you do observations on a weekly basis starting from next week, okay? The instructions are clear there. When you're going to go outside and look at the sky on a specific time of the night, like 9 p.m., for example, okay? And then make observations for the position of the moon and the shape of the moon. That's basically what you're going to be doing for 4 weeks. So you really cannot afford to miss a day. You cannot afford to miss 1 week. This is a mandatory required project that you have to do, okay? You don't have to take your computer with you. You don't have to take your phone with you. All you really need is a piece of paper and a pencil, and basically take the time when you did the observation, the location of the moon, basically north, south, east, west. That's basically, you're not going to be required to have exact coordinates, but estimated values. And then you're going to draw the shape of the moon. If it is a full moon, you're going to draw a full circle. If it is a half moon, you're going to notice which side the lit half is pointing. Is it pointing to the east or to the west, okay? And you draw that, and you continue your observations for, like I said, 4 weeks. After that, you're going to submit your report, okay? If in case one night is cloudy, you cannot do the observations, the following night is okay. Basically, let's say, for example, tonight, I look at the sky and it's forecast. I mean, you cannot see the night sky. You're going to report that on such date when I am supposed to require the report. I couldn't do it because it was cloudy. However, the next day, here is my observations. Now, if the weatherman calls for a week-long, basically cloudiness, hopefully the day before is not going to be cloudy. So in other words, make a judgment in here. If the entire week is cloudy, which is very unlikely in our region, then in this case, you just report the fact that it was cloudy all week and you cannot really make your observations. So this is really one thing that you're going to have to do. This is a required project that we're going to be monitoring, okay? You have the dates on the instructions when you're supposed to do it, and you have to do this project. This is not a choice in it. You don't have an option in it. The other project that was posted actually last week, but it was not available until today, has to do with the retrograde motion of Mars. That one, in a combination with another project you're going to be receiving related to stellarium, most likely about the stars, because we did not really do the stars yet, so I cannot really post that the project yet, but probably I'm going to post it early next week or sometime next week. That one or the retrograde motion of Mars, if you wish. Either one you can do, but you have to do one. Okay. Here is the deal. What you can do all three projects, and then the lowest of the two reports in terms of grades between the stellarium and between the retrograde will be dropped, not the lunar observations. The lunar observation is a mandatory and will not be dropped. So that is basically what we have to do. Those are all the writing assignments in this class that you're going to be doing. So this will complete basically all kinds of tasks that you will be having this week. I mean, in this class, I'm sorry, okay? And they start from today because we have enough materials for at least the two of them. The third one, we probably have to wait a little, but we're going to hit it soon, okay? So let me share the screen. And where is the chat session in here? Okay. Okay. So again, this is what I was talking about. This is the project from last week. Okay. It's worth 61 points. And I'm going to have actually a session this Thursday at 9 a.m. dedicated to these two projects. Okay. We're going to sit down on 9 a.m. Of course, you're invited to attend live. If not, the recording will be made available for you guys to go through it, okay? We're going to go in detail about these projects, see exactly the step-by-step process on how to complete them and get and ace the project. So all you have to do is actually follow the steps in the instructions, actually they're there, and also follow the steps as required by the, and I'm going to show you, and hopefully you're going to have no difficulty with either of these two projects. Let me click on this project first of all, because I'm logged in as a student right now. Last week when we clicked on it, it was not showing the instructions. It was just showing us the rubric. Now it's showing everything because of the fact that as a student, of course, last time I was able to get into it as an instructor and show you the instructions. So right now it is available for you guys, and you can start working on it if you're done with the exam today. If not, tomorrow, of course, if you're not done with the exam, focus on the exam. Then tomorrow, first thing in the morning, you can start working on this. As I said last week, this PDF file is not a requirement. This is an option. You can use it to do your report. And I'm going to discuss this in detail on Thursday at 9 a.m. And I'm going to send you the invitation for everybody so that you guys can basically log in and we can discuss whatever details related to it, because it's quite a bit of work too. I mean, if you think about the rubric and you can see all of the details in the rubric, you can clearly see that it requires time to do this, okay? It's not hard. It's not really a challenge. The biggest challenge is actually to follow the instructions and go step by step meticulously in a systematic fashion, and then complete the whole thing. That is really the biggest challenge. In terms of the actual difficulty inside, there is not, okay? Draw points on a graph. You have the points. You're going to point by point, point by point, point by point, and then connect the points, and you will see actually the retrograde motion. And then you have the formula. We're going to go through the formula. You plug in the numbers, and then based on the numbers, you add them to the days and see how many days and predict when the next basically occurrence of the retrograde will happen. So this is in a nutshell what you're supposed to be doing. And based on the current models, both of them, the heliocentric model, that's where the calculation is based on, which is the correct model, and the old abandoned basically geocentric model where the Earth is the center of the solar system. So this is the stuff that we have to go through to complete this project. Let me go back home to where I was. Again, this is the project I clicked on. The new project that has to do with the lunar observations is, look, this one is due this month, October 23rd, which is in about 3 weeks. We have to have this completed because it does not require any outside observations. All the data is what you have. Everything is basically self-contained. You really don't need to do anything outside. This one is due November 20th. So you still have about a month and 2 weeks to complete this one because it requires a month of observations. A month of every week, once a week, you go outside and you look at the moon. Okay. That's why it says not due this month, because you cannot complete it this month. You cannot complete it in 3 weeks. You are required to do observations starting from next week for a whole month. And then you will have a week later on to complete the report. Okay. So this project is due next month. And let me click on it. I know we have other things to discuss in here, and I'm going to go through them. But let me click on it just to see it, to make sure that it opens. Since I'm logged in as a student, I was able to get into it, okay? It has a rubric also, and the rubric is out of 34 points. The biggest deal in here in this project, honestly, is actually doing the observations. There are questions in there that you need to answer, and we can discuss this on Thursday when we meet at 9 a.m. also. But also, the biggest deal is that every week, and here are the dates, October 13th. October 13th is actually not this Wednesday, but next Wednesday, okay, of next week. So that's the first observation. October 13th at some time at night, when it's night, okay, don't go when it's early in the, when it's still, although the nights are getting basically, it's getting darker and darker sooner. But if you, let's say, for example, it's 9 p.m., that's at 9 p.m. So try to stick more or less to the same time. Of course, if you cannot make it at 9 p.m. because you're busy with something else, and next time you're going to make it at a different time, you're going to record the new time, okay? We're going to record the actual date because it may not be the 13th if the 13th is cloudy. So you may need to do it on the 14th or the 12th. You may need to go Tuesday to do that, or you may need to do it on Wednesday. Okay, as long as it's within a day, your observation should not be too different. The moon does not look too different from night to night in terms of position, in terms of shape also. But from week to week, it definitely looks different and it changes positions. So that's why you have to be very careful with this calculations in here. So what I would say is, if you're doing, starting from this week, you need to plan your next week. What am I going to do on the 12th, which is Tuesday? If I'm free on the 13th and everything looks good, that's actually the ideal day to do it. But if the 13th has some issues, for example, related to family or work or the weather or something, then I probably plan for the 12th. If I cannot do the 12th, then the 14th. I have collected the data, I have to put the time, I have to look at the shape of the moon and the position of the moon, okay? Of course, it's approximate positions, not accurately, okay? So we're not going to get any kind of measurement device and try to do anything too fancy because you're not required to. Again, the week after, which is 7 days after this one, is the Wednesday after that, the 20th. The 27th is the week after this one, and then October the 4th is the last observation. November the 4th, I'm sorry, is the last observation, a month from today. By then, I did all of my observations. I still have to submit this report by the 20th of November, 11 p.m. So that's when I'm supposed to required to submit this report. This is a required report, and the instructions are in here, okay? And there is a file in here actually that you can download and fill. So let me click on it. After I click on it, if I can get, no, it's going to open. It's fine. It's going to open on the browser. I should really have downloaded it. Let me try to click download. Is it still downloading? You don't do this, okay? Download it, you guys, okay? You download this Word file. I was tempted to do it in a PDF file, just like the other project, but then I basically refrained from it. So here, you're going to put your name, okay? And then these are some background information and about the moon phases and how it looks like and everything else, and how it spins around the Earth and the different shapes and things of this nature that you saw. This is what you're supposed to draw. You can draw these things by hand. Or if you know how to draw paint, you can use paint and paste paint in here. So whatever you're going to do, you're going to actually do the drawing. Do not copy and paste from somewhere else, from Google or something else. That is not acceptable. You actually have to do your own drawings, okay? Same thing with your observations. This is not the observations. This is a question related to this activity in here, which we're going to discuss on Thursday, 9 a.m. Now, this is where your actual observations are going to go. Again, this is similar to the intro. So basically the date, the time, the shape of the moon on that date, the moon phase, you're going to tell me what phase it is, and you're going to draw, tell me the position, and you're actually going to draw it in here. And you're going to do the same thing for in and out of all of their observations, and you're going to draw a conclusion based on what you've learned from this activity. Okay, so let me close this and let me go back home. So this concludes basically the introduction to the two projects that we have. We are going to meet this Thursday, excuse me, at 9 a.m. to discuss this in detail. So hopefully you guys will be on in session and we will meet. I will send the invitation. Hopefully as many of you are going to be live to ask the questions that you need to ask. Because if you have something that you probably don't understand or don't see or it's not clear, how am I going to know? I would think that everything sounds clear to me and understandable. So you really are encouraged to attend and ask as many questions as possible to make sure that you understand what you're supposed to be doing and you go ahead and you start working on it. Okay. So this is for these two projects. As I said before, there is a third project that is coming down the road, and that one is going to deal with the stars, is not going to focus on the solar system, because this class has two components, and it has a solar system and it has the universe as a whole, including the galaxy and the stars outside of our own sun. So the other part is going to be outside of for the stars, and I'm going to post the project. I'm shooting for early next week where it's going to be posted, and it's going to be due after we cover the materials in class, okay? So this is basically all the writing assignments in this class. This is what you're supposed to be doing in terms of writing, okay? In all of your writings, you have to please be careful with the way you express yourself in science. I'm not teaching you English. As a matter of fact, I need help with English. However, what you really need to remember is the following, that we are going to be scientists. We express our ideas as clear as possible, as unambiguous as possible, as simple as possible, okay? To explain or to argue or to present information. That is really what I'm looking for in here. That's why the grammar sometimes, not sometimes, all the time, become extremely critical in a sense on how you express things, because the expression that you're going to infer or the image that you're going to basically portray has to be accurate, has to be exactly how it's supposed to be, and the terms used in there are going to be. So in terms of expression, this is why it's important that you really have to have your submission, your writing. First of all, you do the proofreading in a sense that you fix whatever vocabulary that needs to be fixed. You fix whatever grammar that you need to be fixed in terms of how to convey your message, how to convey the information that you're trying to present. And in addition to the facts and the calculations and all of the details. Use complete sentences. And I always emphasize on the fact that you really have to use complete sentences when you present your materials. And do not use short answers. If the question, for example, is asking you, when is the next occurrence of the retrograde? Do not tell me the answer, basically just blank, October 13th, 2027, for example. That's not a complete sentence. You really have to use a verb inside. Just reverse the question and then answer it. Of course, somehow you have arrived to this number based on a calculation, based on the current or the last basically occurrence, plus some numbers that you're going to put in. So now the statement has to be complete in a sense that includes what you know, how you arrive to the information, and the answer. So now we're looking at a paragraph, okay? We cannot just take a number in there because you need to show some understanding, and you show how you get your numbers in there. So that's part of the stuff that is related to this one in here, to this activities in here. When you go and do observations for the moon, and you're trying to report your report, refrain from using certain verbs or certain pronouns. Okay, like for example, I went on October whatever 13th or something like that. Try to refer to it in the third tense. Okay, try to use as much as possible the third tense. The observations that were made on October the 13th. Again, I'm going to go in detail about this one's in here. I'm not going to be too picky about this one at this point, but I'm going to discuss this one down the road with you guys to make sure that your report is as good as it can be. Okay, so these are the projects. And hopefully, as I said, you guys are going to be live with me on Thursday about this too. Let me get into this week's stuff. I know we have the exam. A lot of you really are supposed to be working on it, but let me we still have materials to cover too. So what is the objectives for this week? Obviously, these two projects that I already talked about, assuming the exam is behind us. For those who completed the exam, so you are at this point in here, okay? For those who did not complete the exam, it's an urgent matter. I know I made a big fuss over the fact, do not leave it to October the 4th to do your exam, but some of you opted to do this, so you really are in that basically danger zone, okay? So you really need to do it today before your grade is impacted, okay? So the units that are the unit of this week is unit 41, and it talks about planet Venus. So what we talked about so far, outside of the first midterm, we're talking about the materials that is due for the next midterm. What we talked about the Earth as basically a planet, okay, as an example of a planet. And when we looked at the Earth, we looked at it in terms of its rocky structure, because it's a terrestrial planet, just like we learned a lot from it, okay? And we compared it to other terrestrial planets, namely Mars and Venus, and also to some extent Mercury. And then we learned also about its atmosphere, and the fact that it has an atmosphere, and that gave us some insights about other planets that are mainly atmosphere, if you want to call it this way, because they're giant gas planets, like for example, Jupiter and Saturn. So, and we learned about the weather, what basically what dictates, or what basically constrains the weather on it, and how that actually translates in other planets. And then we looked at the moon, and the moon actually was a beautiful story on its own, because of the fact on how it came to be, and also how it looks like, and the fact that it has some similarities and some differences with the Earth, and how what we learned about the Earth, we took advantage of it, and how we learned about or how we actually predicted the behavior of the moon, or the shape of the moon. And at the end, it turns out that based on our measurements, at least, and observations, it's very close from what we think is. I think we have a very good idea of how the moon came out to be, and also how it's made up of, although there is data that is collected continuously, and research is also always ongoing in terms of our knowledge about the moon. As a matter of fact, we don't know everything about the Earth. Somebody complains that we don't know everything about the moon. We don't know everything about the Earth, so we have to really always learn, okay? So this is basically part of the scientific process, okay? The next object closest to us after the moon is actually Venus. Venus is closer to Earth than Mars. Of course, it depends on the position, because sometimes if they're on the same side, Venus is closer. Obviously, you tell me, okay, Venus spins fast, so at some point it's on the other side and Mars is very close by. Yeah, that's true, okay? But at least in terms of proximity, if you put them side by side, Venus is closer. Venus actually has a lot of other things going for it other than Mars, okay, or even other planets for that matter in the solar system in terms of comparison to the Earth. Venus is the closest object in terms of the solar system objects in terms of mass to the Earth, very close from it. In terms of size also, in terms of all kinds of properties. So it looks like, or at least it was dubbed, the twin sister of Earth, and it is, except that this is not a nice sister whatsoever. This is a super hot planet, okay? And it has a super thick atmosphere. So there are some similarities, but there are some differences. The biggest difference in terms of the two planets is actually the atmosphere by far. The atmosphere on planet Mars, on planet Venus, is super thick compared to the atmosphere on the Earth. As a matter of fact, if you were to stand, and you cannot, on the surface of because of the heat actually of Venus, the air there is so thick it behaves more like a liquid than a gas, because it's super thick. That's in terms of the density. So the air there is much more denser, much more basically much heavier, if you wish, than that of the Earth. Okay, that's one thing. The other thing in terms of the composition, the Earth's air is mainly nitrogen with oxygen in it. The atmosphere in there is mainly carbon dioxide, CO2, okay? Plus some acids, plus nitrogen, plus some other elements. And so this is really a toxic air. It's not suitable for life. As a matter of fact, the other problem with the planet, as you can see from the pictures that the Soviets basically, when they had their lander there, they took the Earth there, or the ground there, is baked by the heat, and the constant and the temperature there can be in the about 800 or 870 Kelvin, which is super hot, which is about 500 degrees Celsius or something, which is super hot, and that can melt lead, basically. There is no electronics, no lander that can survive that much heat. All of the electronics that we use, the microelectronics that we use, probably can sustain maybe 150 degree Celsius or something like that. But you cannot survive in those temperatures, which if we're going to have a lander, and NASA is thinking about to have a mission down the road to Venus, and actually it's a serious project. Most of the project now, they really think on terms of the atmosphere, because of the atmosphere extremely high dense. It's easier to float in the atmosphere, and probably from time to time send probes to the surface to try to see, collect data on the temperature, on the pressure, on the different basically physical conditions and the activities on the planet. The planet itself is marked with volcanoes and all kinds of activities there because of the different activities on the surface. The topology of the surface in there is, it looks like it's water, but it is not water actually. This is basically the lowlands, but it's the highlands. Most of the topology is named in here after women, okay, either real or part of, or the ones that are basically borrowed from mythology, okay, with the exception of this Maxwell Mountains, which is some of the highlands. The lowlands can go as deep as about 8 kilometers, 8,000 meters, which is what, about 25,000 feet. And they can go as much as the same height, okay, 25,000 feet in height. So again, this is based on the radar technology that was used. Radar basically that pierced the atmosphere that was used by NASA to actually see the inside of the planets, basically, or at least under sorry, not the inside, pierce through the clouds and basically see the surface of the planets. So this is basically how it looks like. And obviously there are some modern studies, actually from papers that were published last year, that basically argue that the planet had water not too long ago, about 150 million to 400 to 500 million years ago. It looked like it has a lot of water. As a matter of fact, probably it had more water than the Earth did. But I mean, in terms of the coverage, surface coverage, but probably in terms of the continents, probably less because most of these oceans were probably shallow. Okay, so that's basically part of the studies that were published. And then for some reason, the planet basically started in some sort of a volcanic activities every which way, releasing huge amounts of carbon dioxide, which at the end trapped heat, boiling the oceans, which actually released more heat trapping basically particles, namely H2O, water vapor. And so the process basically, which is really the greenhouse effect in here, became self-feeding. Basically, it became worse and worse. Trapping more heat, releasing more water, trapping more heat, releasing more water. So basically, the greenhouse effect got accelerated, and it went in what was dubbed the runaway greenhouse effect. Today, after that, all of the water basically evaporated. And because of the extreme heat, as a matter of fact, the H2O broke down in hydrogen and oxygen. And because the hydrogen was moving, because of the heat actually, and the oxygen, they were moving super fast. The hydrogen being lighter, it was moved to the upper atmosphere and then lost to the planet. And there is this imbalance in terms of the oxygen now, whatever remnants of it, if it did not combine with carbon dioxide and other stuff. So it's useless really in terms of life forms. The planet now is not really still going in the process. Right now, it's more stabilized. The radiation that hits it from the sun, because of the super thick atmospheric thermal pulse, is actually reflected back. As a matter of fact, this is how the planet looked like from outside. It has a very high reflection coefficient. It basically reflects most of the radiation. Whatever penetrates gets trapped inside. Okay, and the process now is basically it's an equilibrium. It reaches some sort of an equilibrium, basically a no return point. Could the Earth have gone through the process? Potentially, it could have gone. It still has that potential that it could go through the similar situation of how planet Venus went through. If we're not careful enough, or probably because of its natural processes, it could go through the same process. So Venus teaches us a lot about the Earth too, because Venus, in terms of location in the solar system, it is not too far from Earth. As a matter of fact, like I said, the water existed in the past in the liquid form, and potentially also at least in the caps in terms of a solid form. So albeit because it's slightly closer to the sun, it could have had a few degrees higher than the Earth in terms of average temperature, but that should not really have caused what we see today in terms of the planet itself. One of the odd things about the planet itself also is that it's spinning backward. Okay, everybody is going counterclockwise around the sun, basically, including Venus, by the way. It's revolving around the sun counterclockwise, but its own internal rotation is backward, is clockwise. So it's clockwise while it's going around the sun counterclockwise, meaning the sun does not rise in the east, the sun rises in the west and sets in the east on the planet. But the day there is extremely slow day. It takes 243 days to do a full day. The month, the year there is about 7 months and a little over 7 months. So the year there is almost, I mean, a few months, probably a month or 2 months shorter than the whole year. It's extremely slow process that this day spins. Okay, so you go from, let's say, for example, the winter is day. I mean, I'm just taking an example here. Today is day. You have to wait from the fall to probably the spring. I mean, to the winter, but it's moving backwards. So we're going to go from the fall to the summer before we actually go from the morning to noon that day. So it's extremely slow. Imagine yourself on a day that never ends. Okay, that's really how this looks like in terms of its spin and in terms of its internal rotation. And that has an immediate implication, because in terms of the structure, the density and everything, it is not really different from the Earth. We theorize, we don't have really hard evidence for it, but we theorize that because of the fact that they are similar in terms of the structure, they should be identical. In a sense, there is a hard surface, which is the crust, and then you have and as a matter of fact, the crust in there is much more robust. In a sense, there is no plates like the Earth has, plate tectonics. And the plate tectonics plays a major role in terms of recycling carbon dioxide. Because of that, the carbon that is released for the most part stays in there. That's really what caused the planet to also go through the greenhouse effect, through this greenhouse, basically a runaway greenhouse effect. So there are no plates for all the parts, so it's a really solid structure in terms of the shell outside. And there is also a mantle, which is silicate, combination of basically silicium and other material, which is really of the rock that we know of. And then you have a core, which is most likely made out of outer molten, basically iron and nickel, and then the core itself, which is a solid iron and nickel. The problem with it is, although those are two metals, and they have basically high electrons basically available to float in this situation because of the heat that is inside, yet there is no currents in there. Why? There is no magnetism. As a matter of fact, the measurements taken do not show any magnetic field whatsoever. So why is that? Because the planet is spinning so slow around its axis, does not generate enough current inside to cause magnetism. And magnetic field is critical in terms of protecting the planet from radiation, from solar wind and all of the others. But this planet does not need any kind of protection because it has a super thick atmosphere for that, okay? So this is in terms of, I mean, it's really a problem too in terms of the living organisms and things like that. So it is the models that we have for the planet overall. What caused the planet to slow so much and actually move in the opposite direction? There are competing theories and models, basically numerical calculations to try to simulate to see the effect, to see what could have potentially have caused the planet to do this. The leading ones are probably due to the friction with the gas was released so much that basically it slowed down, and because of the winds probably caused it to move backward. Or maybe in its past, or at least at some point, it got hit with some sort of a collision at the right angle. That collision basically caused the planet to slow down and potentially lose a lot of its kinetic energy or something, I don't know. So this is basically part of the theories that are competing in there. We really need to learn a lot about this planet because of the similarities with the Earth and the potential that the Earth could end up in a similar scenario, and see if we can preserve our own life. It really, the more you learn about this planet, Venus, the more you appreciate Earth, the more you really see how valuable this planet is that we live in. Mars does not tell you as much story about the value of the Earth, if you wish, as Venus does. Okay? Venus is really similar to the planet Earth in every which way. Which brings me to another important point, and that is when in our hunt for exoplanets, we usually are basically focused on this region around the stars where the planets could potentially have, or at least not potential, where water in those planets in that region can exist in the three forms: ice, liquid, and gas. Like on Earth, we have vapor, which is everywhere in the air, which is water vapor. We have water, liquid oceans and rivers and rain and all of that. And we have snow every which way, and we have ice that can survive the same. So this is what Earth is. The same thing is actually could have happened in Venus, and it had probably had it in its own past. However, for some reason, it lost that. Mars also is actually in the same region too, okay? where it had all of these things. Now, in our hunt for the exoplanets, we have to really be mindful of this fact. We have to really be focused on this issue, because of the fact that we're looking at stars outside of the solar system, and we're looking for planets in the Goldilocks zone, basically in the zone where water could exist in the three phases. Yet here is on Earth, we have three planets that exist in that one, and only one of them was able to maintain these three forms up to today, and that is Earth. Okay, we will see, or at least for the case of Mars, if we want to contract the two of them side by side, Mars on the opposite has a super light atmosphere. The atmosphere there is so low, and the pressure is extremely low, that the boiling point for water is much lower. Water boils actually at those at lower, much lower temperatures. So that's why Mars could not retain its water. Okay, so as opposed to Venus, Venus lost it because of a different mechanism, which was a heating process coming from the greenhouse effect. Earth, for some reason, it has actually a high enough pressure to maintain water so that it doesn't boil. It boils at 100 degrees Celsius, and it is not as hot as Venus, basically, to lose it completely in the atmosphere. So this is in a nutshell the topic of the week. This is not a replacement of what you guys are supposed to go and I already mentioned the difference in geology between the two planets. And this is not a replacement of you guys going through the reading the content from this week. Okay, this is just an introduction to the topic, and I'll be more than happy to get into more detailed questions if you guys have them and discuss them. Again, this is the week before some of the concept that we, or at least some of the key ideas from the week before. And again, the recording is going to be posted in here. Okay, what are we supposed to say today is that, okay, first of all, we have projects. This week, we're going to meet on Thursday to discuss the projects in detail, okay? So again, the item of the discussion today is, please attend the Thursday discussions for how to do the projects. Attend Thursday, either live or recorded, okay? Ashley did not miss anything, so this is the only thing that we have today. Because of the fact that we have an exam that a lot of you did not complete today, so we did not want to make it a big problem in terms of assignments and activities and things like that. But we have two projects that have been posted so far. And this Thursday at 9 a.m., we're going to be meeting live. And I'm going to go through this project step by step. When we do that, usually I leave it open. Minimum is 1 hour, okay? Meaning that if you attend for 1 hour, you should get all of the information that you need for the projects, okay? However, we can stay as long as you guys want until we finish the project. Usually, typically after 2 hours, we get tired. I get tired, you get tired, and then we lose focus. So we try to limit it between 1 hour and 2 hours. After that, retention and basically focus is lost. So we're going to meet this coming Thursday to discuss the projects. Of course, if they are not clear, if the discussion that we do on Thursday is not adequate enough, if there are more lingering questions, then of course we can do more. We can meet Friday, for example, or I can do an extra session wherever you guys want to. So the point is, we have to do these two projects. I mean, one of them is mandatory and we have to do it, and we have to start this Wednesday. I'm sorry, not this Wednesday, the Wednesday after, October 13th, as the instruction says. October 13th, we have to start working on that project. It is not a choice. It is not like the exam, you're given 4-day window where you're going to say, okay, I don't take it today, I take it tomorrow, I take it the day after, I take it the third day. No, you have to do the projects for the lunar observations on those days. Obviously, I'm giving you one leeway back and forth if you want to for the weather. That's because that's an element we cannot control, okay? But that's a maximum. You cannot really leave it until Friday and you decide, you know what, now I'm free, I'm going to go and do the lunar observation. You missed that observation, okay? So you have to do the next and the next and the next. So that is really the step that we have to consider at this point. So the discussion item today is you have to attend either live or recorded the Thursday session for the projects, okay? And we'll go more in detail about that. I try to divide the time basically evenly between the two projects, going through the essential points and making sure that you guys come up with the enough basically information to be able to finish those projects. Make sense? That's good.
Yes.
Okay, very good. So this is in a nutshell, basically this the units for this week. So I'm gonna stop the sharing. So this is basically the stuff that I have for this week. You will have more assignments down the road in terms of homework, in terms of quizzes, in terms of other materials. But again, because we have this midterm to get it out of the way, so we had to get that out of the way. But at this point, you have discovered everything in terms of assignments, all the kind of assignments that you will have in this class. Homework, quizzes, participation, and all of the other discussion items and everything else. Exams, because midterm is actually still, it's going to be due tonight. And then projects, okay? So those are the 4 different types that you have in this class. If you guys don't have any question, I'm going to stop the recording. And I will see you Thursday.
No questions. Thank you.
Yeah, Ashley, thank you.